Good afternoon, everyone. I'm Sotadeology. In today's video, I want us to treat Sotadeology Lecture 2, full video, mathematical analysis of flipping mechanism of the universe. So, we're going to use time energy wave model to actually illustrate the flipping mechanism of the universe by using this formula of everything. Now, this formula of everything is a kind of formula that iterates. What I mean by that is that it's a formula that feeds back on itself. And what that simply means is that when you insert an input into this formula in the place of this M and this M, you can generate an output, then you can use the generated output as input to generate further output. So this is going to serve, the capital U will serve as the constant speed of the universe. So we have 4 here, and that is what is going to actually instantiate the momentum of what we're going to have here as a weak conveying force. So we have it in kind of suspension. So now I want us to, before I go deep into the Sotadeology Lecture 2, I want to relate our results by using formula of everything to Schrodinger equation, how that is related to it, and we're going to use the uncertainty principle limit to gauge the results that we get. So we can see the limit right here where we have h bar divided by 2. That is the uncertainty principle limit. And so the variation in position multiplied by variation in momentum should actually be from here up to this place. So now let's start with this. This is Schrodinger equation. And so you see that we have I here. That I stands for imaginary number. So we have it to be square root minus 1. I call this flipped induction of complex system beyond the wave boundary. Please take note of that. It's very important because we have the flipping mechanism of the universe beyond the time energy wave constraint. And that simply means that the trajectory of time transcends the substrate dimension into higher dimension. So we have this time energy wave model as 2D, and then it transcends into 3D, and we get the reality by moving into 3D. So that simply means that the dimensional structure of the universe is interlocked into each other. So now we have this term. Let's first of all look at this h bar. This h bar is Planck constant divided by 2 pi. And so we have this to be its value. That is the smallest energy chunk that can exist in quantum system. So that sets the scale at which quantum effect becomes significant. So that one is very important. So this particular h bar is what makes this Schrodinger equation to be operational and functional at quantum level. So now we have this term, which is a derivation of psi to derivation of time. And that tells us how much the wave function psi changes with time. So now we have this whole term right here, and that is the term that we have here is kinetic energy of the particle. And we have another term right here, which is potential energy. Now, when you now look at the whole Schrodinger equation, you see that you have time evolution in time. You have evolution of time as wave equal to the combination of kinetic energy and potential energy. That is what the Schrödinger equation is telling us. So now the Schrödinger equation describes a balance between the time evolution and effect of kinetic and potential energy. But right now there is something so profound that we need to use in gauging our result using formula of everything, because looking at the formula of everything, it has no substance of quantum mechanics in it. So the reason we have it like that is for the fact that solution will have to come from the classical mechanics, even though we have the reality at quantum or right inside the quantum mechanics. So the solution must come right from the classical mechanics into the quantum mechanics, and you will get to know that because you will get to understand why it is so, because we must have momentum and position to be frozen in such a way that we'll be able to measure the two. Basically, if you look at this, I want you to look at this boundary, the uncertainty boundary limit, which is going to serve as our quantum boundary. So now when you look at this limit, the uncertainty boundary limit, you see that it's the value of this variation in position and variation in momentum can't be zero, because the expectation value of the standard deviation should actually be squared, and it can't be zero. And then we know that it can't be negative value, because for instance, let's say this variation in position is zero. It simply means that we are able to know the position, but the variation of this momentum will not be zero if this is zero. And that simply means that this momentum will be infinity, and so we're not going to know the exact evolution of that system in time. So now that we have the boundary, when we divide this h bar by 2, it's going to be this value, and that is what we have right here. Now the value that we have, the quantum arbitrary suspension that we have is this value, and you can see that is greater than this value. So it satisfies this condition of uncertainty principal limit, and that is why reality is so difficult to get at quantum level. But the moment we have the trajectory of time breaking that symmetric nature of light speed, then we'll be able to get reality. But now, is it possible for us to have value from this limit to this zero? Well, if we're to have, there is no experiment or any theoretical research that has broken this limit, but we're going to break it using formula of everything, and then we'll be able to see what we have from this limit to the zero. Basically, for us to not have infinity here, there must be a positive limit boundary around the zero, and we'll see how we are able to have that using the formula of everything, such that we're able to get the flow of time in form of mass formation progression in this region. So that is that. Then another thing I want you to understand is that when you look at the standard formation of power of negative value, you see that, for instance, this particular value is 1000 bigger than this particular value, and that means that as you are moving towards the zero, we have mass density convergence, which it means that the value is bigger. But as you are moving away from the zero, we have energy density ionization, which means that the solidity of the mass density will be will reduce. You understand? So basically, you can see that the system beyond the limit is a kind of flipped system already, and so we are going to dive deep into that. So that is that. So now let's now look at how formula of everything is being derived, such that we now have all the four forces of the universe right inside of it. Now this is the formula of everything. So this particular term 4m is time conveying value. This term is known as strong conveying force. So we have the capital U to be constant value of the universe, which is this particular value. And then we have 4m to be weak conveying force, while we now have this 4 to be time conveying value. That is that. So now the brief derivation of formula of everything is, I use chain rule to derive it because we need to pin down the relationship between time, energy, and mass. And so you can see the formula. So mass is very essential in this formula. And so when you look at this place, these are the terms that we use to configure the derivation. And so the E is going to be 2E. When you do the derivation, the E, the M will be 2M. By chain rule, we're going to have 4E times 2M, and that will be 4EM. So now when we now substitute that right inside this particular term that we have, this term, then we're going to have it to be this, because 4EM will now be this, and then we're going to have this to be 4m squared, which is the strong nuclear force. So strong nuclear force is nothing more than the compactness of electromagnetic field. And so we now have this to be 4m, which is weak nuclear force, and that is the compactness of gravitational field. You understand? So now this strong nuclear force has tendency of spreading out because it defines the nature of energy, which is the default nature of energy, which is infinity. You understand? So now using 4em of 4, so when we now have this placeholder, in order to, the essence of having this placeholder is for us to integrate the EmC square of Einstein. And so by having that in the formula, we now have it to be this particular term. And so here we can see that this particular term is integration of gravitational force. This whole term is the integration of gravitational force, while this particular term is integration of electromagnetic force. Good. So now we now have the value to be this after supplying this is the value of light speed, and this is the speed of sun's gravitational force, because every heavenly body revolves around the gravity of sun. So we're using sun's gravity force, and so now this is the speed of light time, and by that we now have this as our solution, which is dt dm 2.5 times 10 raised power 39 m plus 4m. So this is the constant speed of the universe. And finally, if we substitute this value with capital U, we now have it to be dt dm equals to capital Um plus 4m. That is how we're able to derive that formula. So at the bottom you have link to my research publications. I have 2 publications in respect of that, and I want you to briefly look at this time energy wave model. This is what we're going to visually illustrate the phenomenon in the universe. Okay, so that being said, now let us go to Let us now go to the Sotadeology lecture 2. So right here we have mathematical analysis of flipping mechanism. So basically we're going to relate a dimensional structure of the universe with time energy wave model. So the first thing that we're going to use here is 2D. When you have 2D, the 2D will actually start with 1D, which is what we have here. Now this point, if it is a singularity, we will not be able to identify this point, let alone to label it, if there is no other point to which it is related. And so by having the other point, we can now name this to be Big Bang singularity, while this will now be black hole singularity. Now by having that, there must be this relativity between the two, and that relativity that we have will now be a kind of relativity where there is movement away from zero that will give us energy density as the density of the Big Bang singularity. And then we have another kind of trajectory, which is to be towards this zero that will now give us the mass density that will serve as the density of the black hole. So you can now see that the nature of the singularity of the Big Bang is quite different from the nature of the singularity of the black hole. That difference is necessary for us to have ideal momentum, because there is this smooth convergence of mass which will give us variation to curve time energy wave trajectory. But basically the reason we have suspended region is for the fact that we must have a linear solution right inside the system. So now when you look at where the mass is being forged, you see that you have equal nature of relativity. Where they join, we have the energy density. Now here we have equal nature of relativity. Where they join, we have singularity of mass density. So now, but where we now have the long distance between the two, what we have here is known as relativistic scaling of electromagnetic field to gravitational field. So there is a particular video where I talk about time energy wave field interactions. You can check out the video for you to know more about it. So right now, let's look at this, but I want us to apply formula of everything and then relate it to this time energy wave model. So now let's come down here, application of formula of everything. The T, the M, then we now put our constant right here. We're going to use the value of positron. In this case, it is the same thing as the value of electron, which is 9.109 times 10 raised power minus 31 kilogram. So when we put that in the formula, the answer we get is going to be 2,277,250,000 kilograms, and that is the classical counterpart. We have that being situated right here, and that is the real classical mass worth. Now don't forget that we have mass, we have classical arbitrary suspension right up here, so the trajectory is towards that. Now once we now put this classical mass worth, once we substitute that inside the formula of everything, because solution must come right from the classical realm. So once we put that inside the formula, we're going to get this 5.7 times 10 raised power 48, and that is the suspending value, which is the mass, wave amplitude right here. But look at what happens the moment that is extended. We see that we have a couple of zeros that suspend the electron's mass worth right here at 32nd position. So we need to manually annihilate that, because that value is lower than the quantum arbitrary suspension. So the trajectory is longer than normal. And by manually annihilating that, we now get back to our positron's value. But no, instead of having raised power minus 31, we have raised power minus 32, and that is the effect of decay on this particular value, because the moment it passes through this suspension, there is going to be huge radiation, and that radiation is what is needed to convert electron charge to positive charge to have this positron value. So that is that. So you can see the suspended value right here, and that is the reaction of the action of this gravitational constancy towards this suspension. So once we have this, it must have equal reaction, and that is to form this line. But for us to now have this vertical line, that is where we manually annihilate the suspended zeros that we have here, and that gives us this vertical line, and that is the time instant trajectory from classical realm. This whole region is the classical region, while this whole region here is the quantum region. So we now have the solution from classical realm down to the quantum realm, and even beyond to the positron. Now take note that we have a suspension here, and that is inflationary suspension. Right inside this suspension, we only have electromagnetic field that is being compacted, and that is the strong nuclear force for you. Now here we have another suspension, which is neutron stars suspension. Right inside it, we have compactness of only gravitational field, and that is the nuclear weak nuclear force for you. But in this spacious environment, we have relativistic scaling of gravitational field to electromagnetic field. So here we have gravitational field being increased more than electromagnetic field, and here we have electromagnetic field, relativistic scaling of electromagnetic fields to gravitational field, and here we have an increased electromagnetic field to gravitational field. So now we now know that here we already have relativity to have this long trajectory, but since we have the solution of the formula of everything beyond the constraint of time energy wave model, then we know that the reality of 2D will be domiciled in the 3D here. So now I want us to check something out. What do we have when we surpasses this quantum suspension? What we have here is that we have accumulation of mass towards the 0 point, and so you can see the value that we have here is bigger than this suspension value. That is that. So now that is the whole thing. Now I want you to briefly look at these objectives of Sotadeology. These are the things that you will get to know by getting this particular Sotadeology. So I believe this video is quite informative, so make sure you subscribe to my channel. Thank you. God bless you.